puzzle, you had a couple homework problems. If you're stuck on 3 or 4 from your homework, I'll gladly help you. The best thing to do, though, is just to guess a number for n and use the normal formula n minus 2 times 180. That's the easiest way. Okay, today's 6-2, tomorrow's 6-3. It's supposed to be Friday as a worksheet, but I'm like you, I pray for snow. So, we'll see. So, we're in this section on parallelograms. And there's a little bit we need to know about a parallelogram. Obviously, a parallelogram has a pair of parallel sides. Has 2 pairs of parallel sides, hence the name parallelogram. So, AB is parallel to CD, and BC is parallel to AD. Hence the name parallelogram. It says it in the name. And then if you read this theorem, it's sort of hard to read this. Let me read it to you. It says, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So not only is AB parallel to CD, but AB is the same length as CD, and BC is the same length as AD. They're the same length. What kind of shapes have opposite sides that are the same length? You know, 2. 2 different ones. Opposite sides, same length. They're your 2 favorite shapes. They're the easiest 2 shapes. What are the easiest shapes? A square and a rectangle. Opposite sides are the same length. So one kind of a parallelogram is a square and another kind is a rectangle. Okay, there are 3 properties you need to know, and I would put a star by this because if you don't know these 3 properties, you will not do well on our next test. Okay. The first property is that opposite sides are congruent. Opposite sides are congruent. And that's what that first theorem says. Actually, that's not what the first theorem says. We'll come back to that in a second. The next thing you need to know is that consecutive angles are supplementary. What does the word supplementary mean? Yes, say it louder, be proud. It means they add up to 180 degrees. And the last thing you need to know about parallelograms is that the diagonals bisect. What does the word bisect mean? Cuts in half. So perfect. So let's look a little closer at these 3 theorems. The top one says, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So angle A goes with angle C, and angle B goes with angle D. But these 2 together add up to 180, and these 2 together add up to 180. And that makes sense because the entire thing is supposed to add up to 360. Because if we use that normal formula of n minus 2 times 180, we would have done 2 times 180, which is 360 anyway. So the 2 on the left add up to 180, the 2 on the right add up to 180, and it's perfect because 180 plus 180 is 360. Makes life a little easier. Okay, and then our next theorem says, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary, which is exactly what I was just saying, that these 2 add up to 180, and these 2 add up to 180. But not only is that true, you could do it long ways as well. A and D add up to 180, and B and C add up to 180. Doesn't matter as long as they're 2 consecutive interior. And since we have 2 different sets of parallel lines, we have 2 different options for consecutive interior. And the last theorem is the coolest one of all, and it says that the diagonals bisect each other. So if we have a parallelogram, then this piece is going to be congruent to that piece, and this piece is going to be congruent to that piece. The diagonals are cut in half. Okay, are there any questions? These theorems you don't have to memorize. Seriously, if you'll memorize those 3 properties that I put a star by, that's really what summarizes what the theorems say. Okay, so we only have a couple problems that I'm going to work, and then it's your turn. The first one says, using the figure below, find CF, find the angle EFC, which it would help if it was labeled, and find the length of DF. So they want to know CF, they want to know DF, and they also ask for angle EFC, which is here. They tell you in parallelogram CDF, DE is 74 millimeters. DG is 31, and FCD is 42 degrees. Well, then this should be super easy and you can help me. How long is CF? I would love to hear from someone from Catherine's group. How long is CF? I know you know, that's why I picked them. How long is CF? It is, it's 74. Because the opposite sides are the same length. CF is 74. Because DE is 74. Good. And angle EFC, I would love to hear someone from Jarrell's group. How big is that angle? There are three things we're going to learn about parallelograms. One is that the diagonals bisect. Is you a question about diagonals? One is that opposite sides are congruent. Is your question about the opposite sides? The last one is that consecutive angles are supplementary. Does that help you? What does supplementary mean? Okay, so which two should add up to 180? Which two should add up to 180? You can give me just one letter. It'll be fine. Angle E and what? E and F would add up to 180. And that would be great, but we didn't put any numbers on E. So that doesn't help. So who else can add up to 180? It'd be great if we had some numbers on it. Angle D and angle C. But they didn't ask about angle D. They asked about angle F. So who else adds up to 180? Angle G? I want you to say F, and then I want you to say someone else who has a number, obviously. Which angle has a number? Which angle's angle C? Should they be supplementary? Are they consecutive interior? Are they on the same side? Are they interior? Okay, so if they're going to add up to 180, can I do 180 minus 42? What do you get when you do that? $138. Okay, so angle EFC is 138 degrees. Does everyone understand what Jarrell was doing? He realized that F and E were supplementary. Heck, he realized E and D were supplementary. But we needed C and F because they gave us C, and we were asking about F. So that's why he was going everywhere but the, what they gave him. All the others he listed were correct, though. And last but not least, they asked about DF, which seems pretty easy, but it's kind of a trick. I would love to hear from Derek's group. How long is DF? Go ahead and tell me. Okay, but Derek, I wanted to write 31. They told me DG was 31, so I wanted to write 31 as my answer. Why is it not 31? That's only half of it. They asked for DF. So if I drew it over here, we knew DG was 31, which means GF is also 31, which means the entire length must be 31 plus 31, which is 62. They almost tricked us. Derek called it that. Okay, so let me back up. So Jennifer answered the maybe it was Catherine. So Jennifer's group answered the question about opposite sides being congruent. Jarrell's group answered the question about consecutive angles being supplementary. And Derek's group answered the question about diagonals bisecting. If you know those three properties, you can solve any of the problems we're going to do today. Okay, I have a couple more and then it's your turn. So, of course, we're going to make it a little more complicated, as always. So we have this picture of a parallelogram, and it wasn't enough just to put numbers now. Of course, now they're going to put letters. So they want us to find YZ, and they want us to find the measure of angle Z. Okay, well, I know that YZ is supposed to be congruent to WX, so I know I can do 6A plus 10 equals 8A minus 4, and I can solve for A. Or I could just be smart and probably guess that the A pieces are supposed to equal.
Wait, how do you know that MX is congruent?
That's one of my properties, was that opposite sides are congruent. So WX is opposite YZ. So that's why I know those two are supposed to match. Because they're opposite sides, they're supposed to match. Okay, so if I solve for A, I get 7 equals A. And if I was smart, I'd plug it back in and check myself. So 6 times 7 plus 10, that's 42 plus 10, that's 52. 8 times 7 is 56 minus 4. Hey, that's also 52. So I know I'm right, and I'm getting my A in geometry today. But I've only done half the problem because I found YZ, but I haven't found the measure of angle Z. I need to find the measure of angle Z. So part of me just wants to be a smarty pants and say, oh, I'm just going to set those two B pieces equal and say 18B minus 11 equals 9B plus 2. But I would be wrong. I would love if someone from Sam's group could tell me what I'm supposed to do with those B people. What am I supposed to do? Can I do this? Why? You add them and set them equal to 180. Thank you, Harrison, who wasn't even here yesterday. Thank you, Harrison. 18B minus 11 plus 9B plus 2 equals 180. We know they are supplementary, which means they add up to 180, and you can't read that, so let me write it somewhere else. 18B minus 11 plus 9B plus 2 equals 180. So I have 27B minus 9 equals 180. 27B equals 189. So B equals, I don't know what 189 divided by 27 is. I don't know. I think 7? I think it's 7, but someone should probably check.
That's right.
Thank you. Okay, and then the smart person in me is going to check, so I'm going to plug in 7 for B, so 18 times 7 minus 11, and I would get 115. And if I plug in 7, again, 63 plus 2 is 65. And I know I'm right because, like Harrison said, 115 plus 65 actually does add up to 180, so those two angles really were supplementary. I never said parallelograms were exciting, but if you know the three things, you can do any problem. Okay, we only have a little left. Let's do the next one. I'll leave that there for a second. I still have some people writing. If you want to go ahead, we're going to do that last one with graphing. Go ahead and graph those 4 points. I'm going to let people write. They weren't finished with that problem. Go ahead and graph those 4 points for that very last problem we're going to work. While I get my act together. Okay, so before we get to that graphing one, we have one last one. Miss Thompson's going to do it quickly so you can get to what you need to do. It's about a basketball goal because, you know, it'd be nice if this was actually useful somehow, all this parallelogram stuff. And it's useful in basketball if you really want to think about your shots and your angles. Okay, so they drew this picture, but I'm going to draw it again. So there's M, N, L, K. Mine's not as crooked as theirs. I drew mine a little too rectangular, but it is okay. There's my diagonals. They tell you in the problem that LM is 28. LN, which is the entire length of that diagonal, is 26. And measure of angle LKN, which would be right here, is 74 degrees. They asked for the length of KN. I would love it if someone from Junior's group would tell me what number I can put on KN. How long is KN? It is 28 because it's opposite of ML and they are the same length. KN is 28. Thank you, Sarah. Okay, and then let's go ahead and do the diagonal. I need to know the length of, and I should have labeled O in the middle there. I need to know the length of LO. I would love to hear from someone from Jarrell's group. How long is LO? I would love to hear from anyone. I will accept from anyone. Yes, dear.
13.
Why 13?
That's the full one you have to put in.
Okay, so the entire diagonal, I gotta draw myself a little side picture, was NOL. And we knew the entire thing was 26. And they asked for half of it. So, of course, half of it's gonna be 13. Derek is right. Okay, and then last but not least, they asked for angle NML. NML would be right here. What number can I put on NML? Say it, Catherine.
74.
You can put 74 because we learned that the opposite, yes, these two are supplementary, the two consecutive interior, but the opposite ones are congruent, so it's 74 degrees. Very good. Okay, and last but not least, we have a graphing one. And I've already done J, K, and L, and it asked me where to put M. Obviously, we're very smart. You know M's going to be down here somewhere. It's not going to be up in here in space. It has to be down here in order to complete the parallelogram. Now, if we were smart, we could count up and over. Is that what you're going to tell me? Tell me the coordinates. Tell me the coordinates. What'd you say? 7, -2? 1, 2, 3, 4, 5, 6, 7, -1, -2. He's correct. Let's talk about how he probably figured it out. So, if you count up and then over from K to L, we went up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. We went up 6. We went over 1, 2, 3, 4. Over 4. So I need to go up 6 and over 4. So up 1, 2, 3, 4, 5, 6 and over 4 puts you at, he is correct, 7, -2. So the reason we did that last one, I know it seems kind of random and not like the others, but I've seen ACT questions like this because they test, 1, do you understand what a parallelogram is? And 2, how good is your graphing? Because they're not going to give you a coordinate plane like that. You're going to have to draw your own. So that's why we did this one today, and if you want to make a note, that's a good ACT prep question. Yay! Okay, so of course now it's your turn, and I have an assignment for you. Let me stop my recording. You can do yours.